Okay, today we're going to be talking about domain. Previously, we talked about evaluating for x, plugging and checking for x, and finding y. We talked about if something is a function, that you had to use all the x values from set A to set B, which would be your y values. And I said domain was x and range was y. Domain. Domain is something super duper important. Domain is all the x values, it's all the values that x can take on, which make the statement true. All right? Restrictions for the domain. There are 3 things that you really need to know. 4. 1, if the variable x is in the numerator, then there are no restrictions. No restrictions. However, if the variable is in the denominator, then that means the denominator cannot be 0. If you have even roots, then the expression under, if I'm taking the square root, the 4th root, the 6th root, the 8th root, the 10th root, the expression underneath the root must be greater than or equal to 0. Has to be greater than or equal to 0. You cannot take the square root of a negative number and put you in the imaginary number system. And if I'm taking an odd root, the cube root, the 5th root, the 7th root, then you have no restrictions. So you have no restrictions if your x is in the numerator or if you are taking the odd root. But you do have restrictions if your x is in the denominator or if you're taking an even root. So why is that? Well, let's think about that for a hot second. If I'm taking the square root of 4, so 16, that's going to be 4 times 4, because what number multiplied by itself gives me a positive 16? That's 4 times 4, which is going to give me just a 4. Okay? However, many times you would also say negative 4 times negative 4, so it's going to be negative 4. So a lot of times you guys will put plus or minus in front of it. Again, that's okay. But this is what I need your brain to think about. Well, what number multiplied by itself is going to give me a negative 16? There is none, because it's negative 1 times 4 times 4. 4 is the same number, but negative 1 is not the same number, so there's no way you can get a positive or a negative outcome, and have the same number. So therefore, this does not exist. Does not exist. That puts you in the imaginary number system. And the way we did that is we said I squared times 4 times 4, so that's going to be 4i is going to be your lovely square root of negative 16. However, the cube root is what number multiplied by itself 3 times is 8. So that's 2 times 2 times 2. There's 3 2's inside there, so that comes out as just a 2. Or, how am I going to get a negative 8? Negative 2 times negative 2 times negative 2. A negative times a negative is a positive times a negative is a negative, so therefore it's going to be negative 2 as the outcome here. Okay, so that's why you can take the you cannot take the even root of a negative number, but you can take the odd root of a negative number. Okay, so that's why we have our domain restrictions. So if you have an even root in the numerator, then the junk underneath the root, what I mean by that is the junk under the root has to be greater than or equal to 0, because it's in the numerator. Because the numerator can be equal to 0. However, if you're taking the even root in the denominator, then that means the junk underneath of the radical has to strictly be greater than 0. And we're going to talk about a few of those. So here we go. How do I do a problem like this? Well, immediately, what I'm going to do is I'm going to factor this out. I'm going to pull out what's in common between x squared minus 2x, and that what's in common is an x. So if I fish that out, I'm left with an x minus 2. So my question is, do I have a fraction with my variable in the denominator? The answer to that is yes. So the first restriction that my brain needs to think about is going to be that x cannot be 0 and that x minus 2 cannot be 0. So x cannot be 0 is done, and then x cannot be positive 2 is also done. So x can be any real number. So x cannot be 0 and x cannot be 2. Okay? Now, let's look at a few of the little terms that we just used. Infinity is the largest number in the world. Negative infinity is the smallest number in the world. An open dot excludes the value with the open dot. The closed dot includes the number on it. Brackets include parentheses, exclude. And you never use a bracket with a lovely little infinity symbol. What I'm talking about right here is going to be interval notation. Interval notation. An interval notation, if I go back to this, and I put a number line, I put 0 and I put 2. I have an open dot at 2 and I have an open dot at 0 here. The entire number line itself can be shaded, except for it can't be 0 and it cannot be 2. So how do I describe that? Well, this is what we call set notation. And the interval notation means you read it from left to right. The smallest number in the world is negative infinity, and it goes to 0, and I have an open dot, so therefore it's parentheses. The U means intersection or union, and then I pick right back up where I was, which is 0, and then I go, this shaded region goes all the way to 2, and that is going to be a parenthesis there because it's an open dot. A U again for more shading. I pick right back up at 2, and then it shades all the way to the largest number in the world, which is infinity. That is what we call interval notation. So we're going to do both of these, set and interval notation. We're going to go back and forth so that your brain understands both of them. Okay, so next example, y equals 3x plus 5. What is the domain? Well, how do I figure that out? My first question is, do I have a fraction? There's no fraction. So my checklist in my head, fraction. I don't have a fraction. Okay? Do I have any roots? I do not have any roots. So therefore, I don't have any restrictions, so that means that x is an element of the reals, and it can be any number in the world that it wants to be. Because this is a line with a slope of 3, and therefore the line is going to go on forever and ever in both directions, and therefore x can be any number that it wants to be. Next example, 3x over 4x minus 5. I do not care about the numerator. I care about the denominator. Because my checklist says, do I have a fraction? I do have a fraction, so that means that 4x minus 5 cannot be 0. So 4x cannot be 5, so x cannot be 5/4. So my set notation is going to be x is an element of the reals, but x cannot be 5 over 4. And that makes perfect sense to us. Okay, our interval notation is whenever I put this on a number line. And it's an open dot there, but it can be anything else, so that means I'm shading to the right and to the left. So that means my interval notation means I have to cover the whole number line. So I read this from left to right. So my smallest number in the world is negative infinity, and I go all the way until I hit 5/4. And it's open there, which means it's a parenthesis, and then U for intersection or union. And then I pick right back up where I stopped, and then the shading goes all the way to the right, which means the largest number in the world, which means positive infinity, and then I close that off. That is interval notation. Let's do it again. Okay, do I have a fraction? Nope. Do I have a root? Yes, I do have a root. Since I have a root, I need to now look to see what the root is. The root is the square root, which means I have to be greater than or equal to 0. So I'm going to take the junk underneath the radical, which is going to be 2x plus 7, and that has to be greater than or equal to 0. Why can it be 0? Because it's in the numerator. So if I solve this, I have x is greater than or equal to negative 7 over 2. So my set notation is going to be, I put it in a number family. I have x with my curve E, and 2 lines down for the real number system, R. And then I say x is greater than or equal to negative 7 over 2. X can be any number as long as it's greater than or equal to negative 7 over 2. Then my interval notation is whenever I put it on a number line. Well, here's negative 7 over 2. Can it be negative 7 over 2? The answer to that is yes. So I have a closed dot there, and it's supposed to be greater than or equal to that. So that means I shade everything to the right. So my interval notation means I read this thing from left to right. So as I'm chugging along here, I land in my shaded region at -7/2. And it's a closed dot, which is why it's a bracket. And then that shaded region is going to go all the way to the largest number in the world, which is infinity. And I have a parenthesis because I cannot have a bracket. Okay? Same thing. Do I have a fraction? Yes, I do. The fraction says that the x plus 5 cannot be 0, right? So that means it cannot be -5, because if it is -5, then that means I'm dividing by 0, and that is illegal. Okay, the next thing your brain should be saying is, all right, well, it can't be -5, but it's also an even root, so therefore the x plus 5 has to be greater than 0, because I'm in the denominator, it can't be equal to it, so x is greater than -5. So what we're going to do is we're going to put this on a number line right away. When we put this on a number line, here's -5. This one says it cannot be it, so I have an open dot, and this says I have to be greater than -5, so I shade to the right. That means in the grand scheme of life, this does not matter on my number line. I only take this right here, which means for set notation, I have x is an elm of the reals, and x is strictly greater than -5. My interval notation, well, I first read and run into this graph at the value of -5. But it is an open dot, which means it's a parenthesis, and then the shading goes all the way to the right, which means that's all the way to infinity, the largest number in the world, and I have a parenthesis there. Okay, let's keep going. It looks like it gets harder and harder and harder, but it really doesn't. We're just going to keep asking the same questions over again. So step 1, do you see a fraction? Yep. My first fraction is x cannot be 0. That one's that one. Then I'm going to have x minus 3 cannot be 0, so x cannot be positive 3. That takes care of that one. Then I go to this cube root. Well, the cube root, can I take the cube root of a number? And the answer to that is yes, you can take the cube root of a number because we did that right here with our 8 and our -8, yes? So therefore, I'm able to do this. This problem right here has no restrictions. There's no restrictions on that. I do not have to worry about it. And that brings me to my last one, which is going to be an even root. And that says 4 minus x must be greater than or equal to 0. Why greater than or equal to? Because it's not in the denominator. So if I solve this, I have -x is greater than or equal to -4. When I divide by negative, you must flip the inequality sign. So these are my 3 domain restrictions. So if I put them all on a number line, I have 0, 3, 4. At 0, it is open. At 3, it is open. At 4, it is closed because it can be it, and it says x is less than or equal to. So I'm going to shade all the way down, skipping over 3, skipping over 0, and all the way down to the end of the line. So how do I write this in set notation? Set notation. I put x in the real number family, and I simply put exactly what is in my boxes. Interval is going to be reading this from left to right. So if I'm reading this from left to right, I run into this graph at negative infinity, and I put a parenthesis there. I stop running into it at 0 because there's an open dot there, and that means parenthesis. Then I put a U for intersecting, and then I pick back up at 0, and then I go all the way to the number 3, and that has an open dot in it, so I put a parenthesis. And then I'm going to put a U, then I'm going to pick back up at 3, and then I'm going to go all the way to the number 4, but I'm going to have a bracket there because it is closed. Okay? So that's set notation and interval notation for that. Let's keep going. F of x equals 1 over x plus the square root of x plus 2. Do I have domain restrictions? Well, I have a fraction, so that means x cannot be 0. There's one of them. Well, do I have an even root? I sure do. So now that one means that x plus 2 must be greater than or equal to 0, so x is greater than or equal to -2. So how do I do this? I simply put both of them on a number line. Well, here's -2 and here's 0. At -2, it can be that value. At 0, it cannot be the value, so it's open. X is greater than or equal to -2, meaning I'm shading to the right and I'm skipping over 0. So my set notation, super easy one, X is an element of the reals, and then X cannot be 0, and X is greater than or equal to -2. Interval means we read the graph from left to right. And as we read the graph, we first run into the graph at -2. It is a closed dot there, meaning bracket. I'm going to keep running into this graph until I have an open circle at 0, meaning parenthesis. And then I have a U for union because I have more shading. I pick back up at 0 with a parenthesis, and I continue to the largest number ever, which is infinity, and that's a parenthesis there. Okay? Next. I'm going to go ahead and I'm going to look at this and I'm going to say, okay, well, do I have a fraction? The answer to that is yes, I have a fraction. That fraction says that the x plus 1 cannot be 0, because if it is, then guess what? I'm dividing by 0 and I'm not allowed to do that. Do I have a root? I do have a root. However, I have a cube root. That cube root right there indicates that I have to acknowledge that. I can take the cube root of a positive number and I can take the cube root of a negative number. So therefore, I have no restriction except for this right here, which is going to simply be that x cannot be -1. So my set notation, x is an element of the reals, and x cannot be -1. My interval notation, here's -1, it's an open dot there, and I shade down and I shade up. So that means I'm running into this graph at -infinity to -1, parenthesis, union, picking back up at -1 and going to the largest number to infinity. Okay, I know I'm doing a lot of examples, but it's because this is a very difficult concept, and a lot of times students don't get it until we do all the examples. Do I care about the root on the top? The answer is no, I don't, because it's a cube root. Okay, with that being said, do I care about the denominator? Yes, I do. X minus 1 cannot be 0, so x cannot be 1. So x is an element of the reals, and x cannot be 1. If I graph this, here's 1, it is open, and I shade both left and right, so that is going to be parenthesis, -infinity to 1, parenthesis, union, parenthesis, 1, all the way to the largest number, infinity. Okay, that brings us to the next problem. We take this one fraction at a time. I have x plus 2. That means x plus 2 cannot be 0. So x cannot be -2. Go to the next thing. Do I have a root? I do. And more importantly, I have an even root. So that means the x minus 5 must be greater than or equal to 0. So x is greater than or equal to +5. So before I do anything, I have to graph these, putting -2 here with an open dot, 5 here with a closed dot because it can be it, and I'm shading to the right. Now my question is -2 near the shading? It is not, which means you can throw out that part of the graph, and your answer is simply going to be x is an element of the reals, and x, that is terrible. It doesn't want to write what I'm writing. X is an element of the reals, and x is greater than or equal to 5. Which means I'm picking up at 5, and it can be 5, and I'm going to go all the way to infinity. Okay? That brings us to our last set of notes here, range. How do you read range? Range is read from left to right. Now you have to graph these. There's no other way to do it. So we are going to pull up our graphing calculator, and we are going to graph these so that you can read your domain from bottom to top. From bottom to top. So important. Okay? So, let's wait for my calculator pull up here. So, what this means is is I'm going to go ahead and I am going to pull up a graphs page. Okay. Pulling up a graphs page, I'm going to type in my problem. My problem was the square root of 4 minus x squared. So the square root of 4 minus x squared, and I'm going to hit enter. That is your graph. So as you read this graph, and you're going from bottom to top, so if I'm going from bottom to top, we know this thing is going to look like this, yes? So whenever I run into this thing, I'm chugging along here, chugging along here, chugging along here, and then I finally run into this graph at what y value? That y value that you're running into it is going to be the y value, what? 0. And then it's going to go to what y value? The height is going to be 2. So that means that y is an element of the reals, and that it is trapped between 0 and 2. So you put 0 and 2, and you put y in the middle, and you put less than or equal to symbols. Or interval notation is much easier. It can be 0, and it goes to 2, and it can be 2, so it's 0 to 2. So let's graph the next one. I'm going to hit Control Doc to have a new graphs page, and I'm going to have the absolute value of x minus 2, and hit enter. So again, when do I run into this graph? I run into this graph at what height? The height is going to be your y value. It's at 0, and it goes all the way to infinity. So my answer is going to be, starts out at 0, and it ends all the way to infinity. Or you can say y is an element of the reals, but y must be greater than or equal to 0. Tonight's homework is going to be bookwork 2, section 1, 2, page 26, 47 through 62 all. That is tonight's homework.